Hello everyone and welcome to day 13 of solving LeetCode problems on Tom Hire by FAANG company. Today we're going to be solving 1518 water bottles. There are num bottles, water bottles that are initially full of water. You can exchange empty water bottles from the market with one full water bottle. The operation of drinking a full water bottle turns it into an empty bottle. So given two integers, num bottles and num exchange, return the maximum number of water bottles you can drink. Okay, so for example, 1 we have as our input, num bottles equals 9. Here we have 9 bottles. And num exchange equals 3. So once we have our 9 bottles, we can drink, of course, all 9 of them. And then since we need 3 to exchange it for a new one, well, we're going to have all those 3 and they are going to become 3 new bottles, right? We're going to drink all those 3 and we have just 3 remaining empty bottles, so we can exchange them for one more, and in the end we would have drank 13 water bottles. And again, I believe this is a problem that would require the mod operator, and even though this seems a little bit more like a math problem, which I can imagine it could be done in constant time, here our constraints are telling us something very important, that num bottles is going to be no greater than 100, as well as num exchange, which tells me that we can hopefully use a for loop to accomplish this type of task. Yeah, so let's just go ahead and try something out here real quick with the mod operator. I really like this example, so it's the one we're going to be using to create an algorithm of our own. So of course we're going to be able to drink these initial 15 bottles, right? So res in the beginning is just going to be equal to num bottles. This would be 15. Okay, so now the next thing that we need is to calculate the number of water bottles that we can exchange, right? Which is basically how many times we can divide completely by the exchange number. So for example, if we have the number of bottles is 15 and number exchange is 4, we could probably do 15 over 4, which is the integer of this. This would be equal to 3. And this means that we can drink these new 3 water bottles. So now we're going to have 18. Well, we need also the other residual water bottles that we left, right? Which is actually, if I'm not mistaken, is simply going to be the mod operator, right? So now it's going to have 3 is now going to be like the number of water bottles that we have. So this would be num bottles, right? And we're also going to append whatever was left. So num bottles is going to be equal to, well, num bottles plus 15, which is the original value, mod 4, which in this case is indeed going to be 3, right? So now we're going to have here 3 plus 3 is going to be 6. So we just need to make sure that we don't quite change number of bottles beforehand. This is actually the way we should express this, should be like this, right? So now number of bottles is going to be equal to this, to number of bottles divided by number exchange and number of bottles mod 4, right? And well, as long as number of bottles is greater than number exchange, we're going to keep doing this, right? So this for the moment is going to be equal to 6, like all of this operation. And since it is equal to 6, we're going to keep iterating, basically doing the same thing, right? So res, we're simply going to append here basically res plus it's the division, right, which is number of bottles over number of exchange, which in this case is going to be 1. So the result here for the moment would be 19. And yeah, number of bottles would now become again the residual, which is going to be the same operation, and well, 6 over 4 is going to be 1, plus the residual is going to be 2. We're going to be left with 3, which is less than number of exchange, so we would need to do nothing else. And I believe that would be it for our algorithm. We're just going to be very careful in assigning the new value for num-bottles, and also keep adding new values for res. Right, so we're going to have our res value here, which in the beginning is going to be equal to 0. And this is the number that we are going to return. And here we're going to use the while loop that I was talking about. So while number of bottles is greater or equal the number exchange, we're going to keep doing these operations that I was talking about, right? So first we're going to add the number of bottles to res. We can probably keep them here in a new variable. So add is going to be equal to number of bottles divided by number exchange. Yeah, actually res would be initialized as number of bottles, as I actually mentioned previously during my explanation. So res is going to be equal to number of bottles, obviously. And now while number of bottles is greater than number of exchange, we're going to do this, right? So we're going to add is going to be equal to this. We're going to add this to the res value, res plus equal add. And also this means that this is the number of bottles that we are going to have. So here now number of bottles is going to be equal to this number, which is add. And we're also going to add plus number of bottles mod num exchange. Of course, all of this is going to go inside of our parentheses, and we're going to return res. And if I'm not mistaken, this could potentially work. Let me just be sure that this example again would actually be correct. This would actually work. So let's just go ahead and run this. Hopefully I didn't add any small bug. Okay, that took a while, but our 2 test cases have been accepted, and let's see what happens if we submit this. Okay, and there it is. We have successfully completed day 13. As you can see, our algorithm beats around 90%. Here it says that memory-wise, it's not efficient at all, but really, I believe this algorithm is pretty efficient. I'm just adding some variables to make it a little bit more readable. But yeah, I'm very happy with the solution.